say if you have an object which moves in a circle, or it moves in
Sir,
a circular path. Yes.
sir, are you sharing any screen?
Oh, sorry. I think I thought I have shared, but I haven't. Just one second. So now I think the screen is visible.
Yes, sir.
Okay. So let us say you have an object which is moving in a circle. So what do we observe if an object moves in a circle? Suppose it moves with the constant speed. So it, we have an object moving in a circular path with a constant speed. So we call this motion to be a uniform circular motion. We'll call uniform circular motion as if an object covers if an object moves with a constant speed the constant speed in a circular path. So if an object moves with a constant speed in a circular path, then we call that motion to be a uniform circular motion, right? So here we have the uniform circular motion, that is the object is moving in a circle with a constant speed. So suppose if we have a mass m or any object, here we have a mass m. So this mass m moves in a circle with uniform speed. So we represent here speed. Speed we are representing with the symbol v only, but just writing this vertical lines which will represent the magnitude of speed, magnitude of velocity. Okay, so here v is the magnitude of velocity, or sometimes let's say for this instance we just refer it as by v. So here v represents the speed with which the object is moving. Now, do you think that the velocity of the object is constant throughout the motion? Suppose it's moving in the anti-clockwise direction like this. So do you think that the velocity is also constant?
No, sir.
Yes.
So can you repeat?
What can we say about the velocity of the object which is moving in a circle?
Sir, it will not have uniform velocity.
Hmm? Yes. What all we can say?
Sir, means the object is, where does the object start from?
From any point. Suppose it starts from where I have marked. Okay, wherever I have marked here, that's the point A from where the object starts to move in a circular path. So what can you say about the velocity? Is velocity a constant or is it a variable? That means, does it change?
Sir, it will change the velocity.
It will change the velocity. So how the velocity is changing, but speed is not changing. Yeah. See, if we
Sir,
observe here,
because
hmm,
if it comes back to A, then the displacement would be zero.
okay. See, the actual reason is that at every point, the direction of motion is changing. Okay. So at every point, so it was initially at this point A. Suppose after some time, it is at this point B. So now the direction of motion is different. At A, if I observe from the center, suppose I am observing from the center. So when I'm standing at center, when the object is at A, so to me it will appear as if the object is moving something like this. It will move, I will observe the object to be moving like in this direction. This is the direction of motion which I will observe at the point A. Am I correct?
Yes, sir.
When the object is at B, so I will observe the object to be moving along this direction. And when the object is at this point, so it will seem to me as if the object is moving in the downward direction, like this. So here it will appear to me as if the object is moving. So in these cases, we observe that the speed is not changing, but the direction of speed is changing. That is, since velocity is required with magnitude and direction, okay, we define velocity with magnitude, with speed in a particular direction. But here we observe that direction is also changing. So can we say that velocity is changing?
Yes, sir.
Yes. So at every point here we observe that direction of motion changes. Here we observe that direction of motion changes. Since the direction of motion changes, so we call this that the velocity is changing. At every point we have the direction of motion changing. So we have here a variable or changing velocity. Got it? So even if the speed is constant, still velocity changes here. We have a change of velocity. We observe that velocity is changing. Got it? Yes, I got it. Yes, so everyone understood this. Now let us see why do I say that at every point the direction of velocity is changing. Okay, first let us verify that at every point the direction of velocity will be different. Okay, so suppose if you tie a stone or a ball with the help of a thread and whirl it in a circular path, you are moving that. So let's say something like this. Mhm. Okay, so I need to show you some images here. I have swirling ball. Right, twisting. So something like this. Yeah, like the boy is doing here. You observe here the boy, what the boy is doing here. He's making the ball go around, go in a round, right? He has tied the ball with the help of a thread and he's making it go round. Now, if we observe him, so suppose he releases the ball at this point. Okay, if he releases the ball at this point, the ball will go in a tangential direction. The ball will travel something in this direction. Am I correct?
Yes, sir.
Yes, sir.
Yeah. And if he releases the ball over here, so the ball will go in this direction. At every point, suppose he releases the ball here, so the ball will travel in this direction. That means the direction of motion is tangential to the circle. It is tangential to the circular path. Wherever he releases the ball, so at that point, the ball moves in a tangential direction. See, the same boy has been observed here from the top. So this is the same case when it is observed from the top. So see, when the ball is released from this point, it will travel in the tangential path. So depending
Sir,
on the point of release, yes,
sir, what is tangential?
tangential, okay. So tangential means tangent to the circle. Okay. So let us show, see first of all how a tangent looks like. The tangent to a circle means, see, the tangent to a circle, it means that it will be touching the circle at just one point. So if I draw a tangent to the circle, yeah, a very good question. When I'm saying tangential, so you must know what is a tangent to a circle. Okay, so let's say here another circle I have taken and I draw here three lines. So I have drawn one line here which does not have any interaction with the circle. I can draw a line which is passing through the circle, and I can draw a line which is just touching the circle. Something like this. Got it? So these are the three lines which we have drawn. So the first line which we have drawn, this one, it is very away from the circle, so it does not have interaction with the circle. Now the second line here, which is cutting the circle at 2 points. So this we call as a secant. Such a line, we call it as the secant to the circle. This line is secant to the circle. And this line which touches the circle just at a single point is called as a tangent to circle. So this is the tangent. Got it?
Sir, secant of a circle means the line passes through the circle.
Yeah, the line passes through the circle and it will cut the circle at 2 points, two distinct
Okay.
points. Whereas a tangent is a line which touches the circle just at one point. So when I say that the ball passes tangentially, so that means it will go through the path of a tangent. That means a line perpendicular or a line which just touches the circle at that point. So what I have made here, if you extend this line, you will observe that it touches the circle just at one point. Extend it like this, see, it touches the circle just at one point. So the ball will
Yes.
pass tangential. It will pass in this direction. Got it?
Yes,
Same
sir.
here also. Here also the ball will pass in a tangential direction. Okay. Another example I will show you. One more example I will show you that which represents that motion of a circle, motion of an object in a circle is tangential. Okay. So let's say I'll show you one more picture which will prove that motion is tangential to the circle. Just one. Okay. Sparks produced from a grinder. Okay, see. So do you observe this motion of sparks which are produced from a grinder, which is a cutting tool?
Yes, sir.
Okay. So see, do we observe that the sparks are moving in a tangential direction? See,
Yes,
all
sir.
the sparks here, we observe all the sparks, they are moving in a tangential direction. So this is not a grinder. This is that your I think crackers. Whether it is a cracker or a grinder, I don't know. But we can see here the sparks are moving tangential at every point. They are perpendicular. They see it's moving here. It's moving like this. Here it's moving like this. Here it's moving like this. So can I say that the direction of motion of the particles is different at different places?
Yes, sir.
Yeah. So when an object is moving in a circle, so is the motion is there constant velocity or is there a variable velocity? That means
It's a
if the
variable
speed is,
velocity.
yeah, we have a variable velocity when the object is moving in a circle. So you can see various other examples like mud being thrown from a mudded cycle tire. So here all these sparks which you see here, they are also tangential. At every point, see here, it is tangential. Got it? So I'll also show you the mud coming out of tires. Let's say here, out of muddy tires. Just I want to show just one minute. Motion of mud through. So motion of mud from a muddy tire. Just 1 minute. I want to show you some examples. Okay, see here. I think this example shows us a very good here. See, all the mud that is being moved through the tire, you can see the motion is tangential. Okay. So at every point, we observe that during a circular motion, the speed remains constant, but the velocity is changing. Even if the speed is constant, we have a variable velocity, there is a change of velocity. So can I say the motion to be uniformly accelerated?
Yes, sir.
Okay. So
Yes,
here
sir.
the motion has an acceleration. It's not uniformly accelerated, but it is an accelerated motion. Right? So here we can write that. You can write this is an accelerated motion. The motion of this is an accelerated motion because the velocity is changing. So there is an acceleration. Okay. So every time we need here acceleration, even if the velocity speed is not changing. Okay. So this is an example to set that we can have acceleration even with constant speed. So if you come across an assertion which says that yes, what we will call the assertion to be? Will we call this assertion to be correct or incorrect?
Sir, correct.
Yes, assertion will be correct because acceleration is possible even with a constant speed. Okay. So why in most of the questions which we were solving, we were taking speed and velocity to be the same? Yes. Just 1 minute. Just one. Okay, I'm back. So now
Sir,
I
we
think
take
everyone has. Yes.
sir, we take velocity and speed the same because acceleration we can find with both of them.
See, in most of the questions, they either say the object is moving in a straight line or they say that it is uniform acceleration. Okay. So for that reason, we consider the object to be moving in a straight line. And when an object moves in a straight line without changing its direction, so its speed and velocity will be the same. This is also an
Sir, in
important
that
point.
case, sir, in that cases, the direction is not necessary, no, sir.
No, if it is moving in a straight line without changing its direction. Okay. So the speed and velocity will remain the same. Distance and displacement will be the same. If you are traveling in a straight path like this. So if you travel like this in a straight path and you are not changing your direction. So if you are moving towards the right, so you are always moving towards the right. So can I say that your distance and displacement will always be the same?
Yes,
No,
sir.
sir.
Yes. So that is why for all the numericals which we are solving for acceleration and for second equation of motion, third equation of motion. So over there we are taking speed and velocity to be interchangeable. The reason being that we are considering the object to be moving in a straight line. If the object has a curved path or it changes its direction, so then we cannot say that speed and velocity will be the same. Like in this case, here we cannot say that speed and velocity are the same. Here we say that speed and velocity, they are two different quantities. Now we really realize that speed is a scalar quantity and velocity is a vector quantity. And we define our acceleration as change of velocity and not the change of speed. So here we have acceleration. In this case, we have acceleration. Got it?
Yes, sir.
Okay. Now this specific acceleration which we are observing in the case of circle, it is just changing the direction of motion. Okay. The object is just changing its direction of motion. It is not increasing its speed. So such an acceleration which is always directed towards the center and it changes the direction of velocity is called a centripetal acceleration. Okay. So I provide you another term here, centripetal acceleration. बन गया बन गया Okay. So the centripetal acceleration, it means it is the acceleration that always act towards the center of the circle. So centripetal acceleration, it is the acceleration that always act towards the center of the circle. And an important point is that it only changes the magnitude, it only changes the direction of motion. Direction of motion. It does not increase the speed.
Sir, can you explain the first statement on that circle, sir? I didn't understand.
Okay, the acceleration that always act towards the center of circle is the centripetal acceleration. Right? So here, whatever we observed here, that the motion of the object in a circle, if an object is moving in a circle, so it has an acceleration. This is an acceleration motion, accelerated motion, even if the object is moving with a constant speed. Got it? So even if the object is moving with a constant speed, then also it has a uniform motion. Got it?
Yes, sir.
Got it here? So, but there is a change of velocity, so there must be an acceleration. Now, the direction of acceleration which is acting, the direction of acceleration is always towards the center. You cannot move an object in a circle without holding it at the center. You must apply some force towards the center of circle.
Yes,
You
sir.
must apply some force towards the center of circle to keep that object moving in a circle. Okay. So here we try to pull this towards the center and hence the direction of acceleration is towards the center.
Sir, and sir, would the force required to pull in the center would be centripetal force?
Yeah, the force that is required to keep this object moving in a circle will be the centripetal force. Got it?
Yes, yes, sir.
Yes,
Yeah.
sir.
So here the centripetal force is required, and whenever an object moves in a circle, it requires a centripetal acceleration. So the centripetal acceleration will always act towards the center of the circle, and this acceleration will always be perpendicular to the direction of motion. The direction of acceleration will always be perpendicular to the direction of motion. Got it? And it cannot increase or decrease the speed. What it can do, it can just change the direction of motion. No change of speed is here. However, if an object changes its speed, so that will not be because of the centripetal acceleration. That will be due to some other acceleration. Got it? Anyone has any doubt regarding acceleration or uniform circular motion? I think I have tried a very best to explain you how a uniform circular motion occurs, the directions and the velocity, everything. Anyone having any doubt?
No, sir.
No, sir.
No?
No doubt,
No,
sir.
sir.
Okay. Now say, however, this is not in your class 9, but still I am giving you the formula to find out the centripetal acceleration. Okay. This is for a higher level by which you can find out the centripetal acceleration. And the centripetal acceleration is given by the formula. We write it AC, means centripetal acceleration. So this is equal to V squared by R. Got it?
Yes, sir.
Yes.
Sir, and the
So
velocity, the v square is the velocity at an instant.
velocity V is the speed, not the velocity.
Yeah, yes, sir, speed.
Okay, here V is the speed and not the velocity. Remember, velocity is with the direction. Okay. And in the circular motion, we are looking at the direction. We are observing the change of direction. Got it?
Yes.
Okay. So let's do some questions regarding all of them. We have some questions regarding uniform circular motion and all the topics that we have covered. So in this week, we have completed chapter motion. If you have any doubts regarding chapter motion, so you can ask any doubts or any questions that you do not get. So you can ask that question either this time or whenever you are studying. If you are finding any doubt, you are not having the answer, so you can take a click of that and you can post that in the science group. You have a science support group. Okay. So you can post that question in the science support group. It will be solved and provided the solution to you. Got it?
Yes, sir.
Yeah. So all of you attached to that group or not? Science support group. Just check it at your home. You should be
No, sir.
connected with the science support group, right? Just 1 minute. I'm sharing some of the questions now. Mm. So I'm posting this assignment in the group also.
Okay,
You
sir.
can have access from there, and just now I'll be sharing it on the screen so that we can do some of the questions. Just 1 minute. Let me share in the group first and then I'll be sharing here. Okay, you can check the group. It's available there also. And I'm sharing the screen. You will find it here also.
Yes, sir.
So these questions, they are from the complete chapter. But yes, once you are able to do that, I think you will be able to get a lot from this. So which questions I want to do? Okay, let's do first these questions of graph. question number 21. See question number 21. I think it's visible to everyone. The graph in below figure shows the positions of a body at different times. Calculate the speed of the body as it moves from A to B. Okay. So is it visible to everyone now? Clear visibility?
Yes, sir.
Okay. So try to answer. This is a distance time graph and you have to find the speed. So what is the distance covered in the region A to B?
3
3. So
centimeters.
yeah, this distance covered is 3 centimeter. And how much is the time taken?
Sir,
3 seconds.
3
10
3
seconds.
seconds.
centimeters.
3
3
seconds.
seconds.
Okay, so what is the speed?
1 centimeter.
1 meter per second.
Mhm.
So 1 centimeter per
Centimeter per
second.
second.
1
Yeah,
centimeter
it
per
is
second.
1 centimeter per second. Now, the second part from the part B to C.
Sir, 0.
0, sir, as
0. Okay, from B to C, it is 0. And from C to D,
3 centimeters.
So 3.
see,
4
it is
centimeters.
current.
4 centimeters.
Okay, the distance is 4 centimeter and time is 2 seconds. Is it 2
2
seconds?
centimeter per
2
second.
centimeter per second.
2 centimeter.
Okay. So it's 2 centimeters per second, right?
Yes, sir.
Okay, so now let's see the question number 22. That's also from the graph. The velocity time graph of an ascending passenger lift is given below. What is the acceleration of the lift during the first 2 seconds, between second and 10th second, and during the last 2 seconds? Yes?
Sir, will it be 2.3 meter per second square?
Okay, for the first part, everyone is getting, is there anyone who is not able to get the answers? As I'm going with, if you are answering, so I'm responding. Is there anyone who is not able to get how to find out the acceleration? See, to find out the acceleration, we find out the slope of the graph. Okay. So here the slope will be represented as change of velocity. So change of velocity is 4.6 minus 0 and time is 2 seconds. So you have 2.3 meter per second square. Then between second and 10th second,
Sir, acceleration is 0.
yeah, here acceleration is 0. And during the last 2 seconds,
Sir, minus 2.3
Sir,
meter
it's
per second.
minus 2.3 meter per second.
yeah, in the last 2 seconds, it's minus 2.3 meter per second. Okay, very good. So you'll be doing the remaining questions as a part of your homework. Okay, you have nearly 40 questions, right? We have 40 questions. Okay, so try doing them, solve them out, and if you have any problems in any of the questions, do ask. Okay,
Yes, sir.
okay, so
Okay.
bye all of you. Bye.
Thank you, sir. Bye, sir.